Okay, I know that some people say a partner, it's actually next to their spouse that they will argue the most. Okay, so let me ask Harry first, because Harry is our CMO, and a lot of time I propose some technology concept. He will say, "Hey, Cupid, that doesn't work," and then he will bring me back to the reality. So I will let him to introduce quickly yourself, and then we will go through some questions that I have.
By the way, Cupid's always right in the end. I've learned that from my wife. My name is Harry Kwan. I actually serve two roles. I'm fortunate to, in my day job, I spend a lot of time face to face with folks who have cancer. I treat head and neck cancer, which is a tough cancer to treat. But then again, it's given me a lot of insight in terms of the needs and the challenges of care and the need to be able to collaborate. And to me, that experience has really sharpened me and really made me the person that I am. But it's also taught me the importance of collaboration and data. And in my other role, I work with Cupid. Our hope is to be able to build a different approach to advancing healthcare through improving data and its use for healthcare. So that's me.
Good, thank you. Kenan.
Good afternoon, everyone. Kenyon Crowley, very nice to make your introduction. Thanks for having me. I'm a health information scientist by background. For many years, I've been deeply passionate and involved with how we can use data better to improve health. In my day job, serve as managing director for federal health, data and AI at Accenture Federal, where I work with federal health agencies to build new systems to deploy AI and machine learning workflows responsibly that can help provide insights and provide benefit to patients and beneficiaries. I'm very pleased to be doing that.
Now, Roland.
Perfect. Thank you so much. My name is Dr. Roland Dilling. I'm the Chief Medical Officer for Amazon Web Services, responsible for global healthcare and nonprofits. And I'm also an academic interventional radiologist by background. So I'm still faculty in University College London.
Now you know why we have this panel on, because everyone will have different aspects of the major topic. Can we do it? Can we do it? And the future for healthcare. All right. So, Roland, how about starting from you?
I'd just like to set the scene first of all. When people normally think I'm Chief Medical Officer for Amazon, that means the Amazon Healthcare Services. That's what you're seeing about One Medical and pharmacy and all this stuff that Amazon.com are doing. That's not me. They are a customer of Amazon Web Services. So Amazon Web Services is the largest global infrastructure provider for health and general technology. So we actually run a massive global infrastructure of data centers that democratizes access. So that democratization is really key. So we are integral to democratizing access to data storage, so all the healthcare data that's collected around the world, and computing power. So if you're going to be doing AI, all the chips that inference all of the information that's collected, then processed, and then getting applications into the hands of end users. And so we provide infrastructure that supports the federal government. So Accenture build on top of AWS. We provide infrastructure to healthcare companies like yours, and GE Health, Philips. They're all building their solutions on top of AWS infrastructure, all the way to governments. So I spend a lot of my time speaking to governments about how they are addressing their own healthcare needs. So I thought your talk was fantastic about how we bring these data sets together and to collaborate. These are the topics that governments are talking about. And so again, AWS provides the national infrastructure for the UK, NHS, so the national data spine that connects all of the clinical organizations in the UK, runs on AWS. The National Health Record of Brazil runs on AWS. And we've just got the technology stack for the government of India to re-platform their technology stack to run the Ministry of Health of India's technology stack. So we're in a really, really fortunate position to be able to have these conversations around democratizing access and answering this question, because it's a key question that all of these organizations want to solve. And I do believe that all of the elements that you've described exist today. I think that's the most important thing. And the thing that I'd leave you with is that the democratization element here happens today around the world with various players, but I think bringing it together will be absolutely critical. And it's not a technology problem, ultimately. It's about mindset, people, and processes leveraging the technology, and also understanding the technology, because the technology change is happening so quickly. Trying to stay ahead of it and to understand the capabilities of it is really, really important. And so where we can help to educate is also really critical.
Good, good. Thank you. Good point. Kenan, how about you? You serve the federal client and government client. Do you see the same thing?
Yeah, just to echo, have the pleasure. I mean, the systems that we're building today impact millions of Americans every day. I mean, we're re-engineering how CDC collects data for public health surveillance. We're improving how NCI processes data to advance biomedical research, and helping improve the safety of medical products with FDA and so forth. And the thing I will echo is, while the vision seems futuristic, each of the components to enable the ability to have a more proactive, responsible health system that's able to capture data from disparate sources and make it accessible for insights and engines, all this exists today. Where we need help and support are smart people and students or other who can help orchestrate these systems, right? So when you're implementing AI, and this is something I've been researching and implementing for a long time now, it's critically important that this just doesn't operate in a vacuum. You need to be asking the right questions with AI, and to ask the right questions, that means having diverse stakeholder groups involved in shaping the questions and how that data is going to be used. It also involves making sure we're interrogating the data and the models at each stage of this process, so that we understand that there aren't historic biases or other issues in the data being propagated. If you think about the large language models which are informing this, I mean, the data that has been driving these is based upon historical record and social media and other places that within that data doesn't necessarily represent sort of fair and equal opportunities for everyone. So I think the point that Cupid was making about by enabling access to more diverse representative data for individuals broadly, that has the promise to ensure that the AI going forward is more fair and equitable application of AI. And then we're able to build into the infrastructure of these systems using tools like AWS and others to be able to monitor that. So we know if there are problems with either model drifting from how it was originally trained to provide an insight, and ensuring that there is this, AI flywheel, as you say. So I'll pause there.
Yeah. So Cupid,
Mhm.
you may remember when we started in 2019,
Right?
you started talking to me about this concept.
Mhm.
And I really did think that you were crazy. The reason being is that, but I would answer that question, but now that I actually think we can, it's the simple answer. And what's different from now compared to 2019 is two reasons. One clearly is the large language models. That fundamentally means that we now have algorithms that can understand the questions that we put in and on our internet browser, and then can understand the context of the questions of what you ask, which is before we couldn't with the Google search. By understanding the context and really being able to obviously understand what we call the pattern of the question, it can then give you a much more specific question. And it's this ability to do so, plus the fact that it's now out there for everybody, what we call democratization. But there's another big movement that's going on, and that clearly is the equity of healthcare. So in the United States, there's been a lot of attention paid to what we call social determinants of health. These are major barriers to folks getting care. And it represents our society now understanding that we need to think beyond ourselves. We need to think that we are all in this together, and that we need to start to invest. I'm not saying we have to become a socialist mindset, but we have to start to think of others, because it ultimately all affects us in our pocketbooks and cost. And I would say that it's this movement to more equitable healthcare that is, plus democratization of information, plus now the technology for anyone in this room to go on ChatGPT and say, I'm 26 years old, I've got abdominal pain, I've got some nausea, what's going on with me? It's that ability to be able to do that now, I think, allows us to be able to say, yeah, I think we can do this now.
Mhm.
Yeah.
Okay.
And I think that the environment and timing's perfect.
Good, good. So how about that, Roland?
Well, I can give you 3 data points
Mhm.
about where we're seeing this globally, say 3 facets of this problem
Mhm.
that we're dealing with today. So the first is around Genomics England. So we support Genomics England to do multimodal data integration. So talk about those data silos. You've got text data, imaging data, pathology data, genomic data, transcriptomic data, all these data silos. So we're working with Genomics England to break those down. We're doing multimodal data analysis to look at individuals' risk score when combining all of these things. So you send a person's genome data and their cancer genome data and combine it with all their background data, it will give them a much more specific entity, which then can be targeted. They're also using large language models because the amount of data that comes out around cancers all the time, the amount of literature generated by Johns Hopkins fills libraries. And so how do researchers access the right data to make these decisions? And so Genomics England have actually been using a large language model. So large language models are very like smart interns that are really keen to give you an answer, even if they don't know the answer. So they'll give you a really convincing answer and say, what about this? They're really keen. This looks really good. And unless you know what that answer is or should look like, you may get fooled. And that's a hallucination piece. And so there's some things that can be done called RAG. It doesn't really matter what it is, a retrieval augmented generation, but you can point that large language model at a corpus of data that you know is truthful, and then ask the large language model only to reply based on that data. And that's a really key attribute of this Fed foundation model and generative AI revolution we're in. And so what Genomics England are doing are pointing it at the data that is relevant to it to ask the question of what genes are relevant to certain conditions. And they've identified 20 new genes related to learning difficulties in early life, which weren't previously known, using generative AI. This is a real example of using Gen AI today. Another example is the Cancer Moonshot 2 project we talked about earlier on. So Cancer Moonshot 2 is AWS is supporting Cancer Moonshot 2 as part of President Biden's initiative around the Children's Brain Tumor Network. And they are networking data from 30 pediatric hospitals around the US and hospitals internationally to bring together imaging data, pathology data, text data, genomic data for rare brain tumors in children so that researchers can analyze them. And there is going to be a federated learning platform where this data can be analyzed. And so this is something that's actually happening now. This data is being gathered across all these institutions. The final data point I'd say is, unfortunately, Kingsley Andoa can't be here, but Huron AI, he was going to be one of the panelists. What Kingsley's doing is fantastic. So Kingsley has developed with Huron a large language model, an AI model, which can engage patients in sub-Saharan Africa based on a relevant model to them. And using generative AI, they can actually have an interaction around cancer pathways with patients in a language appropriate model and a culturally sensitive model at an educational level the patient understands. And so in the US, for every 300 cancer patients, there is one oncologist. In Rwanda, there are 3,000 cancer patients for every oncologist. And so you need to democratize access to that cancer understanding to patients. And these are the tools that can do it. So if you take each of those three examples of what Genomics England are doing and what we're doing with Cancer Moonshot 2 and what Kingsley's doing, you can see all of these bits that are building up. But the thing that you're bringing to it is the patient centricity as well. Because if you can give patients access to their own data at the point of need, and you stop relying on the institution to share your data, and the institution being a guardian of your data, and actually empower patients to understand their own health and interact with it, that is really, really powerful.
Thank you. Thank you. So, Kenan, I know that you interact a lot with government. How about from a government perspective, do you see that the need about this kind of platform or the future for that?
Yeah, good question. I mean, within the federal space, there's a whole suite of rules and compliance and regulations, and for good reason. But sometimes this can, slow the pace of progress versus a commercial organization. But within the federal health sector, there's also a ton of very passionate people with, very smart scientists and administrators who want to do things like this to advance services for patients and to advance research. And they're very willing to innovate in this space. And I think we're already seeing that the folks are adopting this in different pockets of agencies. Importantly, in the federal health sector, this past 6 months, there was an OMB AI order or executive order for AI that is driving how federal health agencies must put guardrails and assessments around AI as they're rolling out these programs. Now, as you've articulated this program, I think you've already sort of thought through that at each step in this process, we need to make sure that there are certain checks and balances and guardrails that are being implemented through this process. And I think to the extent that we provide security and robustness in the infrastructure to ensure that those requirements that federal agencies have for deploying AI are met, the promise of what it enables is something that federal health stakeholders are very vested in.
Good. How about from a doctor's perspective now?
From my perspective, I actually think that there is not only a need, but it's entirely possible. The one other point I just realized as I was pulling out my phone, partly to check the time because I know we're under time, but it's this, and it just occurred to me. Everyone has a cell phone now, except for the one person I had dinner with last night. Actually, he finally gave in, but he had not had a cell phone. He's a statistician. I collaborate at the NIH, and he just happened to be the one last human being on this planet that I met last night that did not have a cell phone that his wife actually bought for him. But it is the ability to do so with this now, and this goes across whether or not it's a developed country or a developing country, right? And I think that. First of all, I mean, and we'll talk about whether or not there's a need, but can we do this? This is probably, in my perspective, another reason why we can't. And plus, the cost of cloud storage has dramatically come down. I think the timing is probably incredible right now to be able to capture on this. Not only the needs, and we'll get into that, but we really should be doing things like this. And I applaud Will for the vision of a C4 to be able to bind across. And I think I've mentioned this in my conversation to others in this meeting. The ability to, the problems is so vast, and we've talked about it for years. But I think now is a time where we can actually, by linking data, we can actually now start to gain insights and also then be able to act. Because if you don't have that information, you can't really act. And up until now, I think, in a way, all these efforts globally have a little bit been siloed because we've never been able to share information and understand what each is doing and how we can learn from each other or how we can integrate programs to be even more effective. And I think if we can create that data platform to be able to do so, we can truly accelerate things on a global level.
Great.
Yeah.
Thank you. I know we don't have much time, but is there any final thoughts that you want to share before we go to the next panel, which is the need for this technology?
I guess I would say that I believe that we are living in a truly transformational time, and we have problems that are exponential globally. We have a rising aging population in every country. We have a flat or maybe increasing workforce, even in the UK. So a stat from the UK health workforce in radiology, so my area, is the amount of cross-sectional imaging is increasing year on year by 10%. CT and MRI. The number of radiologists are increasing by 1 to 2%. The recent Lancet Commission on Global Diagnostics showed that 50% of the global population does not have access to diagnostics globally. So we have an exponential problem that we're trying to address with linear solutions. So let's train some more people and let's try and build a few more things somewhere. That's never going to work because you can't address exponential problems with linear solutions. It has to be an exponential solution. And I think that's the promise of the technology that we're looking at today. So looking at 5 years ago, we're saying, well, that's interesting, a bit of a novelty. I think the things that are happening now, so the whole large language model thing, when that hit the airwaves, everyone suddenly went, wow, this is a thing. There's a fundamental step change. Something's happened here. So I think we're living in a really, really exciting time where this technology can address these problems with the right mindset, people and processes behind. And again, our aim is to enable that change. So where AWS can lean in and enable this technology change to be really implemented and introduced, that's where we want to be.
Good, good. Thanks. Final thoughts?
Just one thought on it. I mean, I think the whole concept of mass personalization of one's health data is so critical and what's so powerful about this. I mean, traditionally, healthcare has been somewhat of a shotgun approach. Okay, if this is a 50-year-old white woman with this is what we do, or this is so forth and so forth. But we know that people understand different things differently. We know that people's genes cause them to react differently. We know that different things motivate different people. So being able to apply LLMs and generative AI to get a better understanding and a better interventional approach to fit the intervention to one's individual persona, one's individual phenotype, and other clinical and other characteristics enables, a new opportunity to impact health and wellness. I mean, over the last 10 years, the chronic disease rates in the US and worldwide have skyrocketed. And many of these are driven by lifestyle factors and access to food and other social determinants. By being able to have a better line of sight on these and a better ability to more efficiently and automatically, with humans in the loop, of course, but be able to address these makes me very, very hopeful, very excited to be part of this endeavor.
I'm going to limit my comments because obviously I want to be able to have the next panel on. But my final thoughts are that we're living in a country that I think it's about 17% of our expenses go to healthcare relative to our gross national product, and that's huge. And right now, it's remained stable at 17%, mainly because there's already rationing of care and costs. We just need a different way. There are so many of our patients who have debts due to medical bills. We just need a better solution, and we just can't continue this way. And my hope is that improving quality with transformative Gen AI by not just treating patients, but preventing problems, really realizing that will be one way to get at this, because it all affects us. It all affects our pocketbooks when we continue to spend this much money.
Great, great. Thank you. Thank you very much again.